So we're going to be doing section 12.3, geometric sequences. So geometric sequences have the form of a times r times a times r squared times a times r cubed, where a is the first term and r is the common ratio. And so instead of minusing the difference, we divide them. We divide the two numbers and we'll get what r is, right? Because if I divide this number by this number, I get r. If I divide this number by this number, I get r. If I divide this number by this number, I get r. So if it commonly has r, one of the things I'm not going to do, which I probably would do if we did this in normal class, is I'd give you a sequence and I'd ask, is it geometric or is it arithmetic or is it neither, right? And you'd have to tell. Here, I'll usually tell you if it's geometric or arithmetic right off the top, so you don't have to guess. The nth term of this sequence is of course given by an to the nth term is a to the r n minus 1. All right, so let's actually just kind of crunch through this. So if we have a equal to, so let's just mess with the formula for a second. So if we have a equal to 3 and r equal to 2, define the nth term and find the first 5 terms. All right, so the nth term here would be a, so it would be 3 r to the n minus, oops, we know what r is 2, so 3 times 2 to the n minus 1. So my first term here would be 3. My second term would be 3 times 2, which would give me 6. My next term would be 3 times 2 squared, or this term times 3. Or no, this term not by 3, 2. 2 is my common difference, so this term times 2, so I get 12. And then this times 2 again would give me 24, or I could do 6 times, or 3 times 2 to the third power would be my fourth term. So 4 minus 1 would be third power, which would be 3 times 8, which gives me that. But usually if you're just calculating terms, it's easier just to take your common difference and multiply it. So here would be times 2 will give us 48. All right, so let's just kind of sign the mess with it. So given the sequence, define the nth term. So here we're given a sequence and we want to define what is the a n equals to the ar n minus 1. So here we want a. A is just our first term, so a here is 2. All right. Now, if I take, in order to find out what the common difference is, I'll just take the second term, divide it by the first term, and I get minus 5, right? And then just to double check it, I'll take the third term minus the second term, or divided by the second term, sorry, divided, for doing common ratio, not difference, sorry, common ratio. To find out what the common ratio is, you take the second term divided by the first term, you get negative 5. We're going to take, and then just to check it, you can take the third term divided by the second term. We also get negative 5. So here we know r is equal to minus 5. So a to the n is equal to 2 minus 5 to the n minus 1. All right, we're going to do the same thing here. So given this sequence, define the nth term. So the a is just the first term, which is 1. So we just leave the 1 here. To find out what the common ratio is, we're going to take the second term divided by the first term. I get a third. We're going to take the third term divided by the second term. And if I actually did this, you get a third. So r equals 1/3. And so we can write a to the n is equal to 1 times 1/3 to the n minus 1 power. Okay. All right, so here, so let's pretend we wanted to find the 8th term of this. 8th term's not so bad, you couldn't just do it, but this seems all relatively straightforward. That's good. So here, we want just to find the nth here again. So here we're just going to define n. So a here is 5. This divided by this, so 15 divided by 5 is of course 3. 45 divided by 15 is of course 3, so r here is 3. So here we have a to the n is equal to 5 times 3 to the n minus 1. Now if I want to find a to the 8th, it's going to be 5 times 3 to the 7th power. And this, you just crunch through a calculator. And so I've already pre-crunched it for you guys. It's 10, 9, 3, 5. So that's how you find any term. You just find what the general form is and then crunch through a number. All right, I'll leave this on for 1 second. And we'll go to the next page. All right, so let's do partial sums. So for a geometric sequence, we have this general form, right? And the nth partial sum, so we define the nth partial sum, so s to the n is a plus ar squared, but we're just adding them up, right? So this formula is actually what it is at the end of the day. And so we're just going to use this form. So sum of the first 5 terms of the geometric sequence. So here we have a geometric sequence. Technically, you can just add them up. But let's use the formula. Let's pretend when we just went and just crunched straight through it. Let's just use the formula. All right, so let's first define A. A in this case, so here I want you, so in this time, you guys give me what A is and what R is for this sequence. And then I'll do the next part. So A equals 1, yeah, so A is just the first term. And what is R? R is 0.7, yep, so 0.7. So 0.7 divided by 1 is just 0.7. And then 0.49 divided by 0.7 is 0.7. You don't necessarily have to do this, but it's good just to double check you didn't make a mistake. Okay, so now we have what A is and what R is. And so we're going to say S of the 5th term, S5, is equal to A, which is 1, multiplied by 1 minus 0.7 raised to the 5th power, divided by 1 minus 0.7. Okay, and this is just something you'll crunch into a calculator. And after you crunch it through, you'll get roughly point. Okay. And so if we added up these terms, this is what we would get. The same thing can be done here. I could just multiply this by 0.7 and then have to add up all these, and I'd find out this is what I'd get. All right, let's do this one more time. So here, we're going to find this the sum between 1 and 5, right? For here. Somehow I don't love how I've written this problem. Yes, it's okay. We'll do it all the same. All right. So here, let's actually calculate these terms real quick. So when k is 1, right? When k is 1, we have 7 times 2/3 plus when k is 2, we'll have 7 times 2/3 squared plus when k is 3, we'll have 7 times 2/3 to the 4th, to the 3rd. plus 7 times. I'm writing this out for a reason. I want you to be careful, even though I don't think I asked you to be careful in the homework. To the 5th. Okay. So if we have this here we'd be tempted to say that this is A, right? And if we started at k equal to 0, that'd be our first term, right? But it's not. We're actually starting at this one, right? So we're starting here. And so our first term is really, our first term here is really 7 times 2, so it would be 4. So our first term really is 14 thirds. That's really our first term. And so when we do Sn of our thing, it's 14 thirds. Now, if k was 0, we would use 7 to be our first one. Does everyone see why that is? Yes, no? No. Okay, let's be. All right. I want to find the sum. So this is my sequence I get out of this, right? So my first, this is 14 thirds, right? This is plus 14 thirds times 2 to the third, right? Plus 14 third, because I'm just pulling out one of the 2 thirds, right? To the squared, right? So this is the same way I'm writing this. If k equals 1 and you see this, you have to find out what is your first term, right? What's my first term? Well, if k equals 1, it's this. If k was 0, let me just rewrite this real quick. A simpler one to answer than this one, where k equals to 0, the 5 of 7 of 2 thirds. Because that means if k was 0, I'm going to do 7, or k, because anything is 0 is 1, plus 14, plus 7 times 2 thirds, right? But how many terms do I have in this sequence? How many terms do I have in this sequence? How many terms are in this one? There'd be 6 altogether, right? I'd have 6 terms because I start at 0, which would be my first term, right? Yeah, so I'd have 6 here. And so if I start at 1, I have to figure out what my new A is, right? If I start at 0, I'm here, but I have to I'll be doing S to the 1 higher power, right? So if it was 5 here, it'd go 6. So either way you see these, you have to be careful. So one, either you have to redefine your first term, or if it's 1, you redefine what your first term is, or if it's 2, or if it's 0, sorry. If it's 0, you have to have 1 higher term. So let's do this. So Sn here is, so this is my A, right? So my A is equal to 14 thirds, right? My R is easy, right? It's this. It's 2 thirds. So here I'll have 1 minus 2 thirds to the 5th power over 1 minus 2 thirds. And sadly, I need to calculate this one, which is fine. Let's actually type 1 in. In fact, let's actually do, hello, there we go. Let's actually just type in both because we're there. So I'm actually going to solve this one and this one. So let's go to Wolfram Alpha. Wolfram. There we go. All right, so my first one. So we're going to have 7. So let's do the problem we have first. So we'll have 14 divided by 3 times, oh, be careful about it, times the quantity of 1 minus 2 divided by 3 to the 5th power divided by 1 minus 2 divided by 3. Close, close. Whoa. Okay, so it's a nice thing that this looks correct. And so once we have that, we get, what do we have here? 2,954 over 243. So this is 29. I think I said that number wrong, but I might have written it right. Yeah. 2,054 over 243. Okay. So that's that one. Now, if we did this one, just because this is what you're going to be doing on your homework, notice here we're going to start at 7. So here my first term is 7. Ta-da, my first term here is 7. But here I'm going to go to the 6th because I'll have 6 terms total. And that number here is 4655 over 243. All right, so that's 4655 over 243. Okay, so either way you can do this. Let me see what I gave you on the homework. Homework. Wow. Let me see what I gave you on the homework. That way I'm clear on what I had you to do. Oh, let's see. Website. No. Canvas. There we go. Hello, hello. Homework. Da-da-da. My homework. Yep, find the common ratio in the 5th term and the nth term of this sequence. So I'll give you a couple ones to crunch through. Find the 5th term. Find the 3rd term. So here you'll have to kind of, here we'll use the same rules. I may work through one of the homework with you today. Oh, no, I've always started at 0. So I start at 0, so for you guys, so I start at 0. Oh, this looks excessively familiar. I just flipped the top and the bottom, right? So always just add 1 up here, but you know what your first term is. It's just 3 and 7. So that's what it is for you guys, okay? So you'll be using something that looks a lot more like that. All right. I might do one of those questions with you in a second. If you have x term, how do you find the other x term? All right, so here we want to find this sum. Here, I'm going to go from 1 to what? Infinity. So what am I adding up here? So here, in order to do this, we're going to have to find a pattern because we don't know this yet. Well, at least we're going to pretend we don't know it yet. So S1 is equal to, here I'm starting at 1. And so actually my first term here is a half. S2 is a half plus a fourth, which is equal to 3/4. Here S3 is equal to a half plus a fourth plus an eighth. Well, I know what a half plus a fourth is. It's 3/4 plus an eighth would give me 7/8, right? S4 is equal to S3 plus 16th, and so that's going to be 15/16. And so the pattern here is n s to the n 1 minus 2 to the n, right? So that's what the pattern is. We calculated this last time, or we did something excessively close to it last time. We were adding up stuff. So I guess it was close, it wasn't exact. So here we have the answer, right? So because what happens when I take n? So what happens when I take n to infinity, right? So this number is going to get excessively smaller and smaller and smaller and smaller and smaller and smaller and smaller, right? you know, because if I did 2, 2, I'll just say, let's just crunch it through real quick. Hi, da da da. No, I want one for my phone. Boop. So here we have our solution, right? 1 over 1 minus 2 to the n. So let's just say n was 5. That is, I forgot my little division sign. All right, so we have maybe 2 of that. I think someone unmuted themselves. I'm hearing a little feedback. Thanks, I think it's gone now. All right, so 2 to the 5th, but we're going to get much larger than that. Let's say 2 to the 50th. Well, the decimal approximation, this gets really close to 1, right? And if I get it to like this, well, yeah, it's 1 minus 1 over this insanely small number, right? 1 divided by this number, really small. So it's going to just collapse into 1, right? And so the answer here, let's go back to here. So the answer here is s of infinity is equal to 1. And so we can just keep adding this up over and over and over and over again. We're eventually going to get just to 1. And so for an infinite geometric sequence, so now we can add up an infinite number of things, right? I'm kind of skipping over exactly how this works out because it takes a very long time to build. But here, if given this, if my common ratio is less than 1, I can do this. It'll converge and it has the sum of this, right? My first term divided by 1 over 1 minus my ratio, right? Notice here my first term is a half, my ratio here is a half, and so a half, 1 minus a half is a half, so half divided by half is 1, right? So that works out for this one. If r is greater or equal to 1, this series diverges, as in, if I'm trying to add up something and the number keeps getting bigger, it's going to go to infinity. It'll just be too large. Notice here, because this is, I have a half, my next term would be a fourth, my next term is an eighth, right? Notice this keeps getting smaller and smaller, right? And if it gets small fast enough, i.e. if it's anything less than 1, we can figure out what it is if we take an infinite amount of them. If it doesn't get small enough fast enough, we just say it's diverged, and then we can't do it. So here's what the homework looks like. This is what the exam question will look like. Determine whether the infinite series is convergent or divergent, and then find its sum. All right, so here, let's kind of crunch through this. So, all right. So what's a in this case? A in this case is 2, and r. So we're going to have r. We're going to take our second term, 2 fifths divided by 2 gives me a fifth, right? And if I get to 25th over 2 fifths, if I divide that out, I get a fifth. So r is a fifth, right? So r is 1/5. 1/5 is less than 1, right? Or the magnitude is less than 1. I could have a negative 1/5, right? That's also okay. So if the absolute value is less than 1, so here, this is convergent. So I'll just box convergent, right? And then we're gonna give the value. Well, I guess I should put s infinity here. Let me make a little note to fix this. Let's put s infinity because that's really what we're calculating. So s infinity here is 2 over 1 minus 1/5. Okay, and 2 minus 1 over 1/5. So 1 over 1/5 is 4/5. So it'd be 2 over 4/5. And then I flip and multiply. So 2 times 1. Oops, make that look like a 1. Times 5 over 4. Here, I cross that out, that just becomes 2. So this is just 5/2. So if I add this up infinitely, I'm just going to get 5/2. Let's do this one. All right, here my first term here is 1, right? That's my first term. R is going to be 7/5 over 1, which is just 7/5. Usually, if your first term is 1, this is your R. You can just instantly stay what it is. And I think I give that to you on the homework once or twice. But just to check it, you can do 49 25ths over 7/5, and you're going to get that to be 7/5. All right. Now, is 7/5 less than or equal to, is the absolute value less than 1 or greater than 1? It's greater. So we say this one's divergent, right? And we're done. You can't find its sum. And that's it.